Good morning, everyone. So this is our final example for chapter 1. 80% of these notes today are going to kind of be a review and tying together what we've done throughout this entire chapter. And then there's a little part about misleading graphs that will be new that will also, you'll see questions on that tonight on your homework and also on your review and test coming up. So, yes, I picked a Michigan State example. You guys know me too well, but Michigan State's winningest quarterback in school history is Connor Cook. Connor Cook was a 3-year starter who played during the 2012-2015 seasons. During his senior year, which was 2015, Cook completed 209 of the 368 passes. So that was during the regular season. He completed 209 of the 368 passes. So if we divide those two numbers in our calculator, we get a completion rate of we'll go with 57%. We'll just round it to the nearest whole number for this one. We'll just say 57%. Okay, and then however, Michigan State made it to the 4-team playoff this year, and in the playoff performance during the one game that they played, Cook only completed 19 of the 39 passes for a completion rate of, we'll just round this to the nearest whole number, of 49%. So the question says, use a segmented bar chart. So this was his playoff. We'll highlight these, 19 out of 39. Use a segmented bar chart, so remember that's different than a regular bar chart, to compare Cook's performances in the regular season with his playoff performance. Then we also want you to describe briefly what you see. Okay, so remember, in a bar chart, we have percent go along our vertical or our y-axis. And we're going to go up to 100%. So I'm going to label, put a numerical values on my vertical axis as well. Keep in mind, I like to just label every other increment. I'm going by tens, but just labeling every other increment. So I'm going to have one bar that represents the regular season performance, the other bar that represents the playoff performance. Keep in mind, it doesn't matter how wide you make the bars, you just need to make it consistent. So I'm going to use a width of 4 here. So I'm going to draw it up to 100%, and then I'm going to divide it up based on completions and incompletions. So on my bar on my left is going to represent the regular season. And the bar on the right is going to represent the playoffs. Okay, so I'm going to divide each of these two bars, because remember, a segmented bar chart is kind of like a rectangular pie chart. So we're going to take the rectangles and divide them up. Just like with a pie chart, we take circles and divide them up. So we're going to divide it up into our completions and incompletions, or our completed passes and incomplete passes. I'm going to use shaded to represent completed passes and unshaded to represent incomplete passes. So we are going, now if you didn't know the opposite of complete was incomplete, you can always just write not complete, okay? So if you're not, you know, what's the opposite of a save, a goal, you could always just write not saved, okay? So regular season, up here we did the math, his completion percentage was 57%. So, and remember, shaded is complete. Okay, and then that would mean my unshaded is incomplete. Okay, so that leaves me with about 43% up there. And now you need to be consistent with your playoff bar. Since completed was underneath for the regular season, it also needs to be underneath for the playoffs to make that easy comparison. So it was 49% for the playoffs, and that says completion. That's going to be shaded as well. Okay. And we are missing one more thing for our graph. We're missing a title. It's always important if you're talking about an entire team to list a team. Here we're more focused on the athlete Connor Cook, so his name should certainly be in the title along with the year. Keep in mind, if you play sports, you know your team or your own performance is different from year to year, so anytime you can include the year, that's good to do too. So we'll just say this is Connor Cook's 2015 performance. Okay, and now the last step, briefly describe what we see. So it's easy to make this quick comparison. I can see that this shaded region is higher compared to this shaded region, completed passes. So remember, it's important to talk about the percent because he obviously completed more passes in the regular season because it was over a longer period of time. So it's important to talk about the percentage if you really want to make a good comparison. So Cook completed a higher percentage of passes in the regular season compared to the playoffs. In 2015, Connor Cook completed a higher percentage of passes in the regular season compared to the playoffs. Okay, you could also make reference that his performance was better in the regular season than the playoffs. Both of those would work. So suppose that Cook's ability to complete a pass in 2015 is actually, so look back, which one of these numbers should we use to represent his ability? Okay, remember, the number that would be a better representation is the number that would be out of a more number of attempts. So it would be his regular season, which was 57%. Explain what ability means in this context. If Cook had an infinite number of passing attempts, under the same conditions, about 57% of the time, he would complete a pass. Okay, so remember, it's important to have the infinite number, the millions of trials under the same conditions. So you're assuming they don't get injured or they don't learn a new technique to get better. About what would happen in context, he would complete about approximately 57% of his pass attempts. So we did a simulation with 100 trials, so there's 100 dots on this dot plot off to the right. The ability estimate, remember, is 57% because that's the percentage that he completed in the regular season. Now we're trying to simulate the playoff performance. So how many attempts did he have in the playoffs? That was 39. So each one of these numbers is out of 39 attempts to represent the playoffs. So here are the results shown. Now remember, Cook only completed 19 out of 39. So it was, we're going to draw a line at 19. And remember, it's a poor performance compared to his regular season because it dropped from 57% down to 49%. So we're going to look at 19 and lower. So if we take a second and count the dots at 19 and lower, that would be 15 out of 100. So, based on the results of the simulation, does Cook's actual playoff performance of 19 pass completions in 39 attempts provide us convincing evidence that his ability to complete a pass decreased in the playoffs? No, because according to our simulation, his poor performance in the playoffs is likely to happen by random chance. So no, because according to our simulation, his playoff performance is likely to happen by random chance. With an ability of 57%. Okay, now we're going to stretch our thinking a little bit further with this next question. If we conclude that his ability did go down, now I know this isn't what we necessarily concluded in number 4, but let's say we did conclude that his performance was unlikely to happen by random chance, therefore his ability to decrease. Can we say that it was the nationally ranked Alabama defense that they played in this game as the cause of the decline? Okay, so can we say it was automatically that nationally ranked Alabama defense that caused his performance to be so poor? The answer to this question is no, because ultimately it may seem like that way because Alabama is so good and their defense is so dominating that they were the reason why Cook performed slightly below his ability. We cannot make this direct cause and effect conclusion because there are a lot of other factors involved. And you have to understand that these factors were not controlled for. Therefore, we cannot just directly conclude this cause and effect relationship between his performance and their defense. So what am I saying could potentially be other factors here? You wouldn't have to necessarily list this, but injury. Maybe he was injured. We didn't know about an injury that caused him to do a little bit worse. Maybe he was sick. We play football a lot of time, in Michigan. It's a fall, sometimes goes into the winter, in cold weather. These bowl games a lot of times are played in the South in much warmer weather. So maybe you could there was the difference in weather. Maybe there was a difference in the play calling that the coaches were using. There's lots of things you could list here. Lots of other factors that weren't controlled for, and that's why we cannot directly conclude a cause and effect relationship between these two. So the last thing I want to touch on this chapter is about misleading graphs. When making any type of graph, it is important to avoid adding embellishments that are potentially misleading to readers. Often these additions cause us to violate what's called the area principle. Which states that the area representing each category in a graph should be proportional to the number of observations in that category. Okay, so the following are examples of ways the area principle could be violated. So let's take a look at first example right here with this graph is with three-dimensional graphs. Okay. Now look down at your paper. In the orange section, which is the bigger section, you can see the three-dimensional part of the graph, making it look even bigger than what it really is because you cannot see that part of the graph for the yellow section. Okay, so it does seem to be a little bit unproportional compared to what it's actually supposed to be because you can see one side of the three-dimensional graph, but obviously not the other. A lot of times picture graphs violate this. Taking a look at the picture below, yes, they have the same width, but since they have different heights, it might cause the graph to be a little bit misleading. Okay, so kind of keep that in mind too, is that a lot of times with picture graphs you do see slightly different widths, okay, which cause it to be misleading, and I believe you have an example in your homework like that. Another one is when an individual cuts the axes on a graph. Okay, so for example right here, based on the numbers, the percentages on the y-axis, this bar shows it should be about 33%, and this bar should be about 26%. However, this bar looks so much smaller than this one. There's only a 7% difference, but it's almost like this bar is like 7% times as large as this one, when really the difference is only 7%. So that caused the graph to be misleading because your axis is cut right here, which makes it almost seems like this bar is non-existent when it's still 26%. Okay, and number 4 is when, so the problem right here real quick is that the y-axis does not start at 0. And then another problem that we sometimes see is an inconsistent scale or an inconsistent axis scale. Okay, so if you choose to go by 1s at the beginning, that's fine, but you can't jump and then start to go by 2s and then maybe start to go by 5s, okay, when it's convenient for you. If you choose to use an increment of 1, you got to choose that the whole way through. Okay? So this is the conclusion of chapter 1. So you guys will have a worksheet tonight followed by a practice test to help review all the concepts from this chapter.